All right, composite figures. In fact, the area of composite figures. Since we're talking about area of 2D shapes, the last bit of area that we're going to need to talk about is composite figures. And the question is, what are composite figures? Well, composite figures are one big figure made up of simple shapes, such as triangles, rectangles, trapezoids, and circles. So, if I build a figure, build a rectangle on top right over here, just like that. And let's say that part of the rectangle, actually, let me redraw that. Let's say I draw this rectangle like this. Instead of a full rectangle, I actually draw this instead, which you can call as a different quadrilateral, but this is made up of a rectangle and a triangle. And we can even go even further. We can even, come on. Put a semicircle on top, or about as close to a semicircle as you can in this case. Or even, you can go even further and build a composite shape of several shapes in one. Say we had a square in here, semicircle over here, rectangle juts out. These things can go on forever. And you can have so many different composite shapes. And our job is to find the area of a composite shape. We do that using the area addition postulate. Usually don't name these things, but it's simply the idea that the area of a composite shape will equal the area of the smaller shape. So the area of shape 1 plus the area of shape 2 plus the area of shape X. You can have only two shapes, but you can have multiple shapes. And our job is to find the area of these composite shapes. All right, so I rewrote the measurements for this figure right over here, but we need to find the area of this figure. Now, the key about composite shapes, why composite shapes get tricky, is that the composite shape is made up of several different shapes. And in this case, this composite shape looks like it's made up of different rectangles stacked on top of one another, either up and down or left and right. I'm going to look at it left and right because I have one big rectangle right over here. I'm going to use these dotted lines to kind of separate these out. I have another rectangle right over here. So that makes 3 rectangles. So to get the area of the composite shape, the area, A means area, the area of the composite shape is going to equal the area of rectangle 1 plus the area of rectangle 2 plus the area of rectangle 3. Keeping things simple the way we're writing it down right over here. So we need to find the area of all 3 rectangles. And how do you find the area of a rectangle? It's just length times width. So let's take a look at area. This is going to be rectangle number 1, rectangle number 2, rectangle number 3. Now, I need the length and the width of the first rectangle. This length over here, this is 8 inches. So on rectangle number 1, I'll do it right over here. So 1. The length was 8 inches. The width is, actually that's more the width than the length. So I'll just change that up. The good news with rectangles, it doesn't really matter which one's which, because you're just going to multiply them anyway. Okay, so we need the length. We need the other measure of the rectangle, which is this, and it's not labeled here. And I don't see anything right over here because it's stepping on down. This is where we need to pay attention to all the measurements of the figure, because parts of these measurements is going to apply to this first rectangle we have right over here. We know that this from here to here, highlight that. From here to here, make that highlighter a little bit better. I'll go with this highlighter. Use this one. There we go. From here to here, this side right over here is 4 inches. And that's all we have, 4 inches. But I need the whole length. I need the whole measurement right over here. So I need to know what this part is. Now I see on this side right over here that this is 5 inches. This over here on the bottom is 3 inches. This side is 6, this side is 6. I'm going to hold on to those. But I see from here to here will be the 5 inches. So this side right over here, 5 inches all the way just to there. And then right below that, it's going to be 3 inches from here to the bottom. So that 5 inches goes right here, there. That 3 inches goes right there. And when you put it all together, we have 4 inches plus 5 inches plus 3 inches. So this length is going to be 4 plus 5 plus 3. 3 different parts makes up the entire length of this rectangle. And 4 plus 5, 9 plus 3 is 12. So this is going to be 12 inches. The length is 12 inches, which means the area of the first rectangle is going to be 8 times 12. And put that in your calculator. And make sure you have calculators, folks. 8 times 12 is going to be 96. 8 times 12, yes. And remember, that's not just 96, it's 96 inches squared. That's just the first rectangle. Now we got to move on to the second rectangle. We got to move on to this rectangle right over here. We need the length and the width of the second rectangle. So it's rectangle number 2. So this was rectangle number 1. Here's rectangle number 2. Rectangle number 2, we need the length and the width again, width and the length. The width this time for that second rectangle goes from here to here. I like that tool. We'll use that more often. 6 inches from here to here. That is my width. Now I need my length, which is this measure right over here, but just for this rectangle. So from here down to here, I just need this part right over here. So just need that side right there. Just need that side and only that side, this length from here to here, which is just 5 plus 3, which would be 8 inches. The width is 6 inches. The length is only 8 inches. And 6 times 8 gives you 48 inches squared. That's the area of the second rectangle. The area of the third rectangle, this rectangle right over here, we actually have the measure of the length and the width, 6 and 3. So that makes 6 times 3, 6 times 3, 18 inches squared. And all we got to do to get the composite area of the whole figure, after we break it down, we're going to put everything back together. Whoops. We're going to put everything back together by adding all the different areas. 96 inches plus 48 inches plus 18. Add them together. 96 plus 48 plus 18 equals, put it in the calculator, you get 162. And since it's still inches squared, it's all inches squared, which makes the answer 162 inches squared. Now, composite shapes have multiple parts to that. I didn't write down the rectangle 3, the length and the width right there. Composite shapes get tricky because we have to combine all the different parts. These are longer problems, but these are the steps we're going to need to take. There's no avoiding it. We have to do them. Number 2, find the area of the shaded region. The unshaded quadrilateral is a square. Thankfully, it gave us that. This is, let me write it down a little bit clearer over here. This is 7 meters. This right over here, this measure is actually 5 meters. And that square each side is 2 meters. So we need to find the area of the shaded region. This is a composite shape with a part that's missing. We have this parallelogram right over here, that quadrilateral, that parallelogram, but this part's missing. They took that part out. So instead of area addition, this is going to be area subtraction. So in this case, the area of the composite shape is going to equal the area of the parallelogram minus the area of the square. If there is a part taken out of the shape, we have to take it away. So we need the area of a parallelogram and the area of a square. Both cases, in a parallelogram, we call it base times height. In a square, length times width, but in this case, we can also say side squared. Still length times width because a square is still a rectangle, but it's the same number, so we could just square that one side. And we just go ahead and calculate it out. So we do with the parallelogram, we need the base and the height. The base, 7 meters. This will also be 7 meters on the bottom. So for the parallelogram, do the work right over here. 7 is your base, and your height is 5 meters. So 7 times 5. And 7 times 5 is going to give me 35 meters squared. So that becomes the area of the parallelogram. 35 meters squared. Now I'm going to subtract the area of the square, and the area of the square is just 2 squared. Each side is 2, we square that. So the area is going to be 4 meters squared. So it's going to be 35 meters squared minus 4 meters squared. 35 minus 4, 31 meters squared. Again, you got to put down your units, otherwise you're going to get points taken off. So we have area addition, but we also have area subtraction. You got to watch out to know which one you're doing for which problem. Find the shaded area of this shape right over here. And this time, this is going to be interesting because it looks like they did the part for us right over here, because I have this shape right over here down here, this shape on top right over here. I can even, might be easier if we actually take another split right over here and cut this down. And now I have a rectangle here. I have a rectangle here. I have a triangle here. And I have a semicircle here. Half of a circle. So to get the area of the composite shape, and I'm going to write it on top right over here. Area of composite. Do it in a different color. We're going to take the area of the rectangle plus the area of the triangle plus the area of the semicircle. And I was alluding to it just a little bit, but that rectangle and the triangle, we can also treat this as one shape if we're familiar with the area of the trapezoid plus the area of the semicircle. To keep things simple, I'm going to just do rectangle plus triangle plus semicircle. So I'm going to deal with that. Because the rectangle is, we know the area of a rectangle. It is length times width. And we know that the measurements for the rectangle, we actually have it. 20 millimeters, 14 millimeters, mm for millimeters. So we actually have that, 20 times 14. Here's a 20 for this side of the rectangle. The 14 goes for this side of the rectangle. So we have the two measurements for the rectangle. 20 times 14 will give me 380 millimeters. There's that first one. Now I'm going to try to figure out the triangle. So we know the triangle area, and I'm bringing on the triangle so we can practice the triangle, because that formula is going to be a little bit different. It's base times height divided by 2. Base times height. You got to take the base and the height divided by 2. So the base and the height, we get it from the right angle. There's no right angle here marked, but if I take a look at this, here's a straight line. That has to be a right angle right over here. So that's a right triangle. So that means this side right over here, this can represent the height of the triangle. This can represent the base, which means the height, we know what this side is. It's the same as this side, 14. So 14 times, we need the base. We need that side. But all I have is the full length right over here, 32. And this length right over here, 20. So 20 goes from here to here. From here to here is actually 32. So if I go 32, take away that 20, what's left over is that part for that triangle. And 32 minus 20 is 12. So it's 12 times 14 divided by 2. And real quick, 14 times 12 divided by 2. Put that in the calculator to get 84 millimeters. And remember, those are square units. Can't forget that. Now we got to figure out the area of a semicircle. Now, the area of a circle is pi r squared. There is your area of a circle. But what about a semicircle? A semicircle is half the circle. That means whatever the area of the circle is, got to divide it by 2. Pi r squared over 2 for the semicircle. And if you have a quarter of a circle, it'll be pi r squared over 4. Just a small tweak to our circle area formula. And we need the radius, which is the middle of the circle, to the edge. I have this measurement right over here, from here to here. On that semicircle, that's 20 millimeters. That goes from edge to edge. I need halfway of that. I need half of 20, which would make the radius 10. So pi times 10 squared over 2. And it's telling me to round to the nearest 10. I'm going to do that in a little bit. So this will be in the calculator. I'm going to need my calculator's pi for this. 10 squared, so 100 times pi. And divide that by 2 to get approximately 157.0796, and I'm gonna round this at the very end. I'm gonna use 4 decimal spots for right now. So 157.0796 millimeters squared. And now, to find the area of the whole shape, I'm going to take all 3 areas and add them together. So 380 plus 84 plus the area of the semicircle, 157.0796. Add them all together, we get approximately, and we're going to round this to the nearest tenth. I'm going to round it to the nearest tenth. 621.07907 rounds up to 1 millimeters squared. And again, use your calculator's value for pi. Use the pi button on the calculator if you have to deal with circles. Last problem. We have a triangle with a mini semicircle taken out. So this time, this area of the composite shape is going to equal the area of the triangle minus the area of the semicircle. So again, area of the triangle equals base times height over 2. Base times height, it has to be taken from, their base and height are always perpendicular from one another. So if the triangle is rotated this way, to find the base and the height, look for the right angle right over here. And the 2 lines that are perpendicular, forming that right angle, will be the base and the height. In this case, it's a right triangle, so we're actually in luck, because we just have 18 and 26. So 18 times 26 over 2. Put that in the calculator to give us, this is an exact number, 234, and that's going to be feet squared. That's the area of the triangle. Now I got to find the area of the semicircle. Again, it's a circle, pi r squared, cut in half, divided by 2. So we need the radius, and this radius, the semicircle has a measurement from here to here of 9 feet. So the radius has to be half of 9 feet, so 4.5 feet. So pi times 4.5 squared over 2. So put that in the calculator. Multiply that by pi. And we're going to cut that in half to give us approximately 31.8086. I'll just leave it right there. That decimal goes on forever. And now, feet squared. To get the area of the shaded region, take the area of the triangle and subtract the area of the semicircle. 234 minus 31.8086 going on forever gives us approximately 202 point. I'm going to round it to the nearest tenth. I got 202.1914. 19 rounds up to 2, and move it to the side so I can write down the unit. Feet squared. We don't have to add feet squared to feet squared because when you're just adding, just like in algebra, the units just add together. Feet squared just stays the same. That's the warm-up, and that's the notes, excuse me. Those are the notes for composite shapes.